There is a barn in Lancaster County that has not had a squeaky hinge in 40 years. Every tool on the wall moves smoothly. Every bolt threads clean. Every drawer slides without resistance. I walked through it on a wet November morning, and not a single hardware made a sound. I asked the farmer what he uses. He walked to a shelf, picked up a small tin, and held it out. Boiled linseed oil. Cost him $2.47 at the hardware store. The same tin has been on that shelf for 8 months. He uses it on everything. He has never owned a can of WD-40. Here is the number that reframes everything you think you know about that blue and yellow can. WD-40 was invented in 1953 by the Rocket Chemical Company in San Diego. The name stands for water displacement, 40th attempt. It was designed for one purpose: preventing rust on the outer skin of the Atlas ballistic missile program. It worked. Then someone at Rocket Chemical noticed workers were taking cans home to use on their own hinges, and in 1958 they put it in stores. The product that became the most purchased lubricant in American history was never designed to lubricate anything. That is what the datasheet says. WD-40 is approximately 50% mineral spirits by volume. Mineral spirits is a solvent, the same class of chemical used in paint thinner. When you spray WD-40 on a rusty hinge, the mineral spirits dissolves the rust and oxidation, creating an immediate sensation of smoothness. That sensation is real. But solvents evaporate. Within 48 to 72 hours, the mineral spirits has largely evaporated from the surface. What remains is a thin petroleum residue that actively attracts airborne dust and metal particles, the things that accelerate wear in any joint. The application that felt so effective on Monday has, by Thursday, left behind a surface that is slightly stickier than before you applied anything. The friction returns. You apply more WD-40. You buy another can. WD-40's own safety data sheet classifies it as a petroleum distillate-based product. Their technical data sheet does not describe it as a long-term lubricant. It describes it as a penetrant, a moisture displacer, and a light-duty corrosion preventative. Those are not the same thing as a lubricant. Professional mechanics, machinists, and gunsmiths do not use WD-40 as a lubricant. They use it for exactly what it is designed for: loosening seized fasteners and displacing moisture. Then they apply an actual lubricant afterward. The consumer market never learned this distinction, because the marketing since 1958 has positioned it as the universal solution for anything that squeaks, sticks, or resists. Boiled linseed oil is a different category of product entirely. It is not a solvent. It is a drying oil derived from flaxseed. It is heat processed to increase its polymerization rate. When applied to a metal surface, it does not dissolve surface oxidation and then evaporate. It penetrates the microscopic surface structure of the metal and undergoes a chemical polymerization reaction with oxygen. This is the same reaction that causes paint to cure from liquid to solid. The result is not a coating sitting on top of the metal. It is a cross-linked polymer that is bonded to the metal surface at a molecular level. That bond does not evaporate. It does not attract dust the way petroleum residue does. It forms a flexible, durable film that remains lubricating and protective for months. The mechanism was understood by craftsmen long before WD-40 existed. Viking ship finds from Scandinavia contain traces of linseed oil on iron fittings. These fittings have survived in a polymerized state for over 1,000 years. Not because linseed oil is magical, because a cross-linked polymer bonded to metal at the molecular level is more durable than a petroleum film sitting on the surface. When WD-40 appeared in stores in 1958, it offered something linseed oil did not: instant gratification. Spray it, the squeak stops immediately. Linseed oil takes longer because it requires time to polymerize and bond. The consumer market rewarded the faster result. The traditional lubricant retreated to the farm supply shelf where the Amish still find it for $2.47. 2 rows over from the blue and yellow can. Without the marketing. Without the television advertisements. Hinges. Remove the hinge pin if accessible. Apply boiled linseed oil to the pin and barrel with a small brush or folded cloth. Reinstall. Work the hinge through its full range of motion 10 to 15 times. Apply a second coat to any redistributed surface oil. Silent and smooth within 4 to 6 hours. Reapplication needed approximately once per year. Stuck bolts. This is where WD-40 and linseed oil work best together. WD-40 for initial penetration. Its solvent action on rust is aggressive and fast. Apply, wait 20 minutes, attempt the fastener. Then clean the threads and apply boiled linseed oil before reinstalling. The linseed prevents the fastener seizing again. WD-40 alone leaves residue that attracts moisture and accelerates the rust that causes the next seizure. Tool handles. The most dramatic long-term difference. Wooden handles crack and split when the wood dries. The Amish apply boiled linseed oil to every wooden handle twice per year. The oil penetrates the wood fiber, maintains moisture content, prevents cracking. A handle replacement costs $15 to $30 in 45 minutes. The linseed oil application costs 15 cents and 5 minutes. Apply with cloth. Work into wood. Wipe off excess. Allow 24 hours to dry. Bicycle chains. Apply sparingly to a clean, dry chain. Work through the derailleur several times to distribute. Wipe off excess. Polymerizes into the link pivots. Resists washing off in rain better than petroleum-based lubes. Reapply every 4 to 6 weeks. Cutting tools and saw blades. A thin wipe before storage prevents rust and maintains glide through wood. Apply with cloth, wipe to a thin film, allow to dry. Works on plane blades, chisels, and handsaw teeth. Prevents rust without leaving a thick oil film that would contaminate workpieces. Raw metal rusts when iron reacts with oxygen and water simultaneously. WD-40's water displacement creates a thin hydrophobic layer that repels water, but only briefly. As the petroleum layer evaporates, the protection disappears. In a humid environment, a WD-40 treated surface shows rust initiation within 2 to 4 weeks. Boiled linseed oil works differently. The polymerization reaction that cures the oil consumes oxygen from the air above the surface. Once cured, the film presents an oxygen-impermeable barrier to the metal beneath. Without oxygen reaching the surface, the rust reaction cannot initiate. The cross-linked polymer also has significant hydrophobic properties. The tinsmith and blacksmith traditions across Europe before the 20th century relied on linseed oil for exactly this reason. Tools stored with linseed oil remained rust-free through winter in unheated barns. The Amish barn I visited in November had tools on the wall with no rust on their metal surfaces, despite storage for years. Not because the barn is exceptional, because the practice is consistent. The total economic picture: 1 quart of boiled linseed oil, $8 to $12, sufficient for 1 to 2 years of complete household lubricant and tool care needs. WD-40 for equivalent coverage, $36 to $54. Over 10 years, $360 to $540 versus $80 to $120 in boiled linseed oil. A difference of $280 to $420 from a product that also outperforms WD-40 on every measurable metric. The 2.47 tin on the Lancaster County farmer's shelf has been on that hardware store shelf since 1891. It was there before WD-40 existed. It is there now. 2 rows over from the blue and yellow can. Without the marketing. Without 67 years of consumer habit built by a product that does something different from what most people think it does. Drop in the comments what you use WD-40 for most. Hinges, tools, bikes, guns. I will tell you the exact application method. The shelf that replaced traditional knowledge did not erase it. It just moved it 2 rows over and stopped putting it in the advertisements. It is still there. It has always been there.